Let's ask for some practice exercises on operator overloading. Now, what I'd like is to do a mixture of exercises involving operators that stand on their own, so basically operators that look like regular functions, and operators that live inside of classes. And I wouldn't mind if some of these exercises also give me an excuse to practice writing classes, but as usual, I don't want to prejudice the output too much. So I'm just going to start by saying, give me some operator exercises, and then refine my prompt if that turns out to go nowhere. I want to practice writing code for operator overloading in C++. That is C++ 20. One of these days I got to see what happens if I don't say C++ 20. Can you generate 3 programming exercises involving operator overloading? Should I ask for starter code? Yes, I think I should. So I think this is one of those topics where having starter code gives you a better picture of what this is actually like. Because if it just gives me a prompt saying, write some code that does this, create an operator, then I have too much control. I would sort of like it if it generates a main function that uses the operator and I'm forced to work around its use of the operator. For each exercise, generate starter code with some operators or or functions missing. Let's say for each missing function, for each missing operator or function, generate a formal specification in the form of a header comment. And then I'll say, for each exercise, create a main function with test cases for the missing operators. Don't show me the solution. Now, we saw in the last, or over the last couple of videos, I've developed a suspicion that recently I've had to argue with it quite a bit because it doesn't generate starter code that I like, that maybe that has to do with the fact that I'm asking for 3 exercises at once. So maybe it only has a certain amount of brain power it's willing to spend on me because I'm cheap and I haven't paid for the subscription. And so maybe it will simplify the request if I'm asking for too much stuff at a time. So if that's what happens here, I'm going to just ask for 1 exercise. Because in the last video, once I started probing, once I said, hey, for this exercise, give me something better, it was able to do it. Let's take a look. Certainly. Okay, we'll see what it does. Something about complex numbers. Okay, that's interesting. There's main. Looks like we're going to have multiplication and addition operators. Okay. Matrix. All right. Weird. A 2x2 matrix. Okay, fair enough. I don't know that I want to do something too tedious, so I might refine this a bit. Like I get it. I may do this. And then exercise 3, fraction. Okay, so I am not doing fraction. And the reason is because if I recall correctly, there are several videos out there in the video sequence for 116 about fractions that I think are in the operator. Like they're this week's videos. I'm not going to go check right now, but I'm sorry, ChatGPT. I'm afraid this has already been done, right? A bit late to the party. Okay, so we've got 2 that seem viable. Let's just go grab complex. The issue I have with these 2 is that they're both very like arithmetic based, and I'd like to have at least one that's something different. Although if I have to be careful what I wish for. If I ask for that, it might just say, oh, do a student database or something. Okay, so I'll paste it over. Let's take a look at what it came up with. So it's a class called complex to represent complex numbers, which means that this exercise might be a little bit impenetrable if you don't already know what a complex number is. I don't know that I can give you enough of a description that makes any sense off the top of my head. So basically all I can say is that a complex number is a number that has or can have both a real and imaginary component. We might choose to write a complex number like this, where I, maybe I should write I in some special notation, I don't know, cursive or something. I is the imaginary unit. So I is a value that when squared equals -1. Or better yet, we should write it like this. If you get into some weird, the further into complex mathematics you get, the more you might realize that writing that I equals the square root of -1 is oversimplifying things. We can define other systems like quaternions where there are multiple square roots of -1, which is tons of fun, but we're not going to do that in this exercise. Anyway, a complex number has both a real component, which in this case would be the a, and an imaginary component, so a multiple of I, which would be the b. We often draw complex numbers using this sort of 2D representation. So because we can think of the complex number as a pair of things, the real part and the complex part, and we can actually draw it out as a particular place on a 2D plane, even though it's just one value. So we can almost think of a complex number in a very weird, loose sense in terms of how we represent it as a sort of vector with two elements. Okay, that's all I'm going to say about that. Until I have to implement the operations, I guess. If you want to know about complex numbers, go look. I'm sure the Wikipedia article on complex numbers is pretty informative and probably more accessible of a description than whatever it was I just said. Okay, so I've got this complex, I've got a constructor. I guess the complex number, it looks like I haven't been given any private members, so I'm going to have to make those up myself. I think that the names it's used look good, so I'm going to call them double real and double imag. Now, I should add that I think I've mentioned this in a previous video. Both C and C++ have built-in complex number types. So if you ever actually need a complex number, you should use the built-in complex number type that's somewhere in the library. I don't know off the top of my head what it is because, to be honest, I never use complex numbers in C and C++, but they're in there, so you don't need to write them yourself. Okay, so it looks as if the and I'm just going to it looks pretty clear what it wants me to do here. I'm initializing my member real to be the parameter that was given to me called real. I'm initializing my member imag to be imag. And then we're just going to leave the rest of it blank. All right, so I need two operators. I need a plus operator and a multiplication operator. And I think that that's it. It's given me a pretty nice specification here. So my interpretation is that a complex number, when I add it to a different complex number, I'm going to return another complex number. So I'm going to say complex operator plus, and so the plus operator on complex numbers takes two arguments, and those arguments are going to be the left-hand side and the right-hand side. However, when I define an operator that lives inside of a class, remember that by default, the current object, that is to say this, becomes the left-hand operand. So the operator itself takes only one argument, which would be complex. It actually wants me to use a specific reference type. So I'm going to say, I would rather write it as complex const reference other. Okay, so this is the same type. I've just written it with a different order of words. So the idea here is that the plus operator actually has two operands, but the first operand, the left-hand side, is the current object, and the right-hand side is the other object. Okay, so I guess what I want to return, so when you add two complex numbers together, so if I've got Z1 equals A plus BI, and, A plus BI, and Z2 equals C plus DI, if I try and add those together, well, let's just do that. So Z1 plus Z2 is apparently equal to A plus BI plus C plus DI, and collecting terms. If I want to write this result as a complex number, it would look like A plus C plus B plus D all times I. So if I make a new complex number, the real part is A plus C, the imaginary part is B plus D. So I think what I'll do is I'll say complex result, and then I'll just call the constructor to initialize the two members. The real part will be the real part of this plus the real part of the other. Now real is private, but remember that I'm inside the complex class here, so I'm allowed to use private members. And then the imaginary part of my result is the imaginary part of this one plus the imaginary part of the other one. So there we go. I'm wondering if I can test this yet. I'll look at the testing code. Oh, that's interesting. Okay, so it didn't tell me to do this, but evidently I need to write something that allows me to print out my complex numbers before I can test it. Okay, so it doesn't say this. I'm going to actually give it a hard time for that. In exercise 1, do I also have to implement one of these operators to allow printing of complex objects? I want it to acknowledge that it built in a hidden extra. Okay, so I'm not going to, oh, actually, okay, so yes, it would be a good practice. I don't think it's just a good practice. I don't think main is going to work. Okay, here's an updated exercise. Okay, it's going to show me some of the answers, so I'm not going to look at that. Okay, I'm going to head over here. I'm going to try compiling this, and I want to prove that it is going to complain. Yeah, you can see that clearly the compiler has indigestion. Okay, it's going to take me a while to find it, so I'm going to do this. Yeah, there's a lot going on here. Keep scrolling, keep scrolling, keep scrolling. Hope I don't run out of scroll space. Did I find it? Nope, keep going. Well, okay, maybe I'll just call it. I'm going to suffice it to say that I think it suffices to say that this is not going to compile. So I think the reason this is complaining, although I don't think I can even find the first error. It's so far up. Oh, there it is. Okay, finally. No match for operator multiplication. Okay, that's fair enough, and that's probably going to make a mess. But then the real mess comes out of this. It needs this operator. I'm trying to push my variable sum, a complex number, into an output stream. All right, so I'm going to have to write an operator. Now, I've mentioned in another video, so in one of the lecture videos, that when you write this operator, it has to look like this. And there are reasons for that. Please look at the lecture video for an explanation of why that is, because I'll just be repeating myself. So I have to make it, the operator I'm writing is this operator, the stream insertion operator, as applied to a complex number appearing as the right-hand operand. Now, why is it the right-hand operand? Again, go take a look at the other video, but basically it's to allow me to write this. This is the most basic use case of that operator. You can see here that the complex number is the right-hand operand. Because it's the right-hand operand, I can't put the operator inside the complex class, because remember that when you put an operator inside of a class, the current object, that is an instance of that class, becomes the left-hand operand. So I'm stuck. I'm left with no other choice but to write this operator. I write it living in the wilderness, so not inside the class. I'll call this stream, and then I'll say complex const reference, we'll call it C. And then I guess what I want, if I want to print out a complex number, is, oh, actually I should ask, what's the output format? What is the expected output in exercise 1? I don't think it told me that already. Okay, here's the expected output. So it's expecting that when I print out a complex number, I print the real part, a plus sign, and then the imaginary part followed by the letter I. Okay, that seems simple enough. So what I'll do is I'll say, okay, into my stream, I push first the value of c.real, and you can see there should be a little alarm bell going off right now because c.real is private. So I'm not inside the class on line 30. I'm just out in writing what amounts to a regular function. This function doesn't have access to .real, so I'm going to have to work around that. And then I'll do plus, and then I'll put c.imaginary, and then I'll put the letter I. And then that's the end. That's all there is to it. I don't put a new line because that's somebody else's problem. Then I return the stream. And this is the way a typical printing, a stream insertion operator looks. As I said, there's a separate lecture video about that. Let's go and do the multiplication operator on our complex number, or at least write something so that the code compiles. So when I multiply two complex numbers, the result is a complex number. So I'll do multiplication, and then it takes complex const reference other, and then I'm just going to return nothing here, so I'll just say complex result, and then we'll just have that be 0, 0, just so that this code will compile and run. Okay, return result. Let's just see what happens if I compile this now. It's going to so now it's going to complain that, sorry, these are private. You can't access them because in the place that you're using them, line 35, you're not actually inside the complex class. So what do we do? Well, okay, there are two things I think here. One, for a real complex number object, it does seem like you need to define a way for the outside world to access real and imaginary. So in one sense, I'm inclined to sort of add a get function here. So I guess I could do that. Double get real, and then, whoops, and then I just return real. And then double get imaginary. Now, the complex number type that the language provides doesn't have access control, because really we think of complex numbers, the way I would normally use them is more like one of those basic structures from early in the course. I don't need access control for a complex number because it's just a pair of real numbers, the real part and the imaginary part. In that case, it is sort of convenient, just allow me to directly access the members. But this is an exercise in writing operators and on access control, so whatever. Okay, I'll just call these functions get real and then get imag. Whoops. There we go. That should make the error go away. Oh, yep, right. Okay, so this is actually a topic from this week, so I should know better. I've got a couple of other issues. So one of them is in my plus operator, I'm noticing this warning here, line 18. It's pointing out that in my plus operator, I made a result variable, but I never returned it. Okay, so that's now done. That's a typo fixed. And then it's still complaining about get real and get imaginary. This complaint is basically that in the operator I wrote, I decided to take my complex number by constant reference, which means C is a constant object as far as I'm concerned, which of course means I'm only allowed to call member functions if they don't modify the object, if they promise not to modify the object. And I think we saw that in this week's material, but that to actuate that, the get real and get imaginary functions do not modify the object. And so I'm allowed to put the const qualifier at the end of the signature to indicate that you can call these even on a constant object. So I'm going to try that. I think, okay, that solves the problem. I'm going to now run it to test out the plus operator. So the sum of 2, 3, and 1, negative 1 should be, so 2 plus 1 is 3, 3 plus negative 1 is 2, so 3 plus 2i. And that was the output that ChatGPT expected as well. Okay, now I need to compute the product, so I have to use the multiplication operator. And so just to sketch how I'm going to think about that, so Z1, suppose we have Z1 equals A plus BI, and Z2 equals C plus DI. Remember that I squared equals negative 1. So I is a square root of negative 1. So what is the product Z1 times Z2? Well, that's going to be A plus BI times C plus DI, which is going to equal, okay, so that would be AC plus ADI plus B, or I'm gonna rearrange the terms in these multiplications, but B times I times C, so BCI plus BI times DI. Well, okay, so BI DI, I don't need to write it down here, I'll just write it out and then simplify. BI DI, which equals, I'm going to try and collect terms together to the best of my ability, AC plus, and then I'm going to combine these two things in the middle here, AD plus BC all times I, plus, okay, what is BI/DI? Well, that would be BD times I squared, but I squared is negative 1, so that's going to end up equaling AC minus BD, because I squared is negative 1, plus AD plus BC all times I. So if I want to write this product as a complex number, this is the real part, and this is the imaginary part. So that's what I'm going to do. For the sake of making it to make it easier for me to understand this formula, I'm actually inclined to just sort of to say double A equals real, double B equals imaginary. So I'm actually going to pretend as if the current object is Z1 in this example, and then I can just write the formula that I've derived here instead of having to try and figure out what other.real and other.imag are in each case. Okay, so then double C is others real component, and double D is others imaginary component. Okay, so then what I'm going to do is when I create my result, I can just use the formula that I've drawn there on the right. So the real part is AC minus BD, AC minus B times D. The imaginary part is A times D plus B times C. All right, so we'll try that out. Looks like that compiled, and it gives us 5 plus 1i. Now, I should verify this by hand because ChatGPT can't always be trusted with math. Okay, so a is equal to, we've got, in this example, it's 2 plus 3i times 1 minus I, or 1 minus 1i. So AC times, so this would be C, this would be D, this would be A, this would be B. AC is negative 2 minus BD, So that's B is 3 and, oh, sorry, AC, not AD. AC is 2, BD is, B is 3, so that's minus negative 3. So this is going to be 5. The real component should be 5. It looks like it is. That's good. And then the imaginary component is AD, which is negative 2, plus, and then BC is 3, which is going to equal 1, which also looks good. So I think that's complete. I'm going to call the exercise complete at this point. Now, obviously, it can be argued that maybe I should do a bit more testing of different complex numbers. So a couple of things. One, although I do believe these formulas are correct, because I just had to come up with them on the fly, maybe there's a typo in them. So if there were a bug in that, I don't think it would affect whether all the operators work. Operator overloading and writing classes is something where the type of testing you do is a bit different, because a lot of the testing is done in the compiler. Like if the code, getting the code to compile is often the hard part. So I'm going to call the exercise complete. If there are numerical problems with the algorithm, that's because this is not a course in complex arithmetic. Go take some other course if you want to learn this kind of math correctly. Okay, so that's done. One other note I'm going to make, though, is if I had insisted, so if earlier I had said, no, you're not allowed to write extra get functions, if I demand that we have real and imaginary access directly by this operator, remember that the compiler won't accept this. It's going to say, sorry, you're not allowed to access private members. If I don't allow myself to write get functions, I guess the only option here would be to add a friend directive. So to say, this operator gets to have private access. And to do that, I'm going to have to, let me see, is that going to compile? I may need to declare it elsewhere. Okay, yeah, that worked. So you can see here that the friend directive, as we know, is sort of an escape clause. We shouldn't really make the habit of using it too often. This is a rare example where the friend directive would be justified. Although I still think we probably want get functions. If we didn't have them, it makes sense. This operator is doing something that's close enough to what the class, internal to the class, that it can be a friend. Also, because we would add this operator to the class if we were allowed to, but we're not allowed to. So a friend directive is the only way to bring it in. All right, that's exercise 1 taken care of. Let me just clean everything up here. Okay. I'm actually going to revert back for the sake of saving this exercise for later. I'm going to go back to this version, the one that has the get functions. Okay, let's try another one. So practice operators 2, and we'll go and take a look. What else did ChatGPT suggest? So we've got, oh, actually, let's skim over the solution to exercise 1. Or whatever it suggested. So ChatGPT, when it generated me the answer, looks like it's the full answer here. It did a couple of things that I wouldn't do. So first, in the class, you can see that all it's written are definitions, or declarations. There aren't any definitions. It's declared the constructor and the two operators and this stream insertion operator. Notice that it used the friend directive. So it decided not to create those get functions. It also used a funny naming convention for the members, but there's no easy solution to this. Then here's the constructor. Notice how it's written on the outside of the class, and so it has to use this namespace notation to get into the class. There's the constructor. That's not too surprising. There's the plus operator. It's doing pretty much the same thing I did, where it just makes a new complex value with the constructor and then returns it, although it's saving one line by just returning, by calling the constructor directly, by constructing a temporary object instead of making one with a name. It's also using round brackets, which, whatever. And then there's multiplication. I imagine it's probably the same formula I came up with because it gave me the same output. And then here is its stream insertion operator, which looks pretty much the same as what I wrote, and it was given the friend directive. All right, okay, let's look at exercise 2. So exercise 2, I'm going to copy this and I'm going to look at it. I may ask for a replacement because it might end up being tedious. And I mean, it's one thing to do exercises to build character, but if the exercise itself has no relevance to what you want to learn, then there's no point. So it looks like we've been given a class to represent a 2x2 matrix. So like basically I'm interpreting this as you've got this matrix and it's A, B, C, D. That's it. It's always 2x2, so you won't even bother with vectors or arrays. You'll just use 4 double values. Okay, so now I want to define an equals operator which is peculiar for a reason that I'll get to in a minute. So are the two matrices equal or not? This is looking a lot like a lab exercise. And then a plus operator to add them together. Is that literally it? Yeah, maybe I won't do this. This doesn't look like it's any different really than exercise 1, especially because although this is a matrix, not a complex number, it's still just going to be 4 double values instead of 2. What I will note on the way to discarding this exercise is the equal sign is neat because normally when you want to compare two things that involve floating point data, you wouldn't do actual equality comparisons. You'd test whether the difference between them is bounded above by some value. So that is, because floating point numbers are inherently sort of inaccurate, there's a little bit of inaccuracy or rounding error, you don't necessarily want to use a regular equals comparison. Instead, you want to say these two numbers are considered equal if they're close enough together that basically they're within a rounding error of each other. It's unclear if that's what ChatGPT wanted me to do here, but I'm gonna ask it for a replacement exercise that's not as arithmetic oriented, I think. Can you generate another exercise in the same format? Preferably an exercise without, I don't want to say not as, like, less mathematical, but that's sort of what that would bring across my point. That depends less on math. Okay, let's see what it came up with. Certainly. Okay, this seems to involve strings. Here's an exercise that involves operator overloading but depends less on complex mathematical operations. All right, let's try this. This looks okay. That's weird. I mean, that's a very peculiar task. But it's contrived. But whatever, we'll give it a try. All right, so we've got a class called string concat, and this represents string concatenation, which is weird. I mean, because we can do string concatenation. But okay, we're basically writing our little wrapper around the default string concatenation. It's forgotten to include string.h for some reason, so I'll just go ahead and do that. Okay, and then so the idea basically is you create two of these objects. I'm going to use curly brackets. You create two of these objects, and then you can add these string concat objects together, and you can print them out. Okay, well, I'll try that. So basically, this looks like a very thin wrapper around what a string is. I just keep a string internally, so we'll just call it S. And if you use the plus operator, then I create a new string concat object that represents the concatenation of the string stored in this object and the string stored in the other object. That's pretty much it. Okay, so I'll initialize my member S to be str. That's good. I'll write my operator here. It returns a string concat object for some reason. This is operator plus, and again, because it lives in the class, I have to write, it takes only one argument explicitly, which would be the other operand. So that's string concat const reference other. And then it appears, I'm going to try using notation similar to what ChatGPT did in its earlier solution. Instead of creating a new object and returning it, I'm just going to create a temporary object and return it along the way. So I'm going to return a new string concat instance that contains the string contained in this object plus, using the strings plus operator, other.s. And that's literally it. And then here, I need to define a stream insertion operator again, but just like last time, I can't put that in the class. I have to put it outside and make it a friend or do something similar. So here I'm going to write, it's going to return std ostream, and we're going to do operator this, and then it takes as its arguments a stream on the left and a string concat object, const reference, on the right. So I'll call that SC, I guess. Okay, and then what it does is it's just going to push into the stream the string stored inside of, so .s, that is this member here, stored inside of the object that was given. And that means, of course, that because that's a private member, I have to make this thing a friend. I sort of like what ChatGPT did, where it just put the friend directive right where the exercise was. So I think this is the exercise. This is a pretty ridiculous exercise because you're defining something that has less functionality than a string, but is basically otherwise a string. Like it uses all the operations of std string. But I feel for it. I mean, when you're writing programming exercises, it's really hard to come up with lots of interesting ones. Even ChatGPT can't quite do that. I made a mistake here. I forgot to return something, so we'll just return the stream as usual in this case. try it again. It runs, or it compiles, and there it is. I'm not going to do any more testing. I think we can see that I have implemented a plus operator, it compiled, and that it does do concatenation. You know, on balance, I'm not too happy with this. Let's ask for a new one. That's fine. Can you generate another? Okay. Define a class called time. Okay, this sounds better. And the time class contains hours, minutes, and seconds. Define the overloaded operator plus to add two time objects. And then we define less than. Okay, this is good. And then I define a print operator. Okay, so ChatGPT loves asking me to define printing operators. I'm looking at this and noticing there are a couple of things that are going unspoken. Let's ask it for the model output. So what I want to think about here is it says time is stored as hours, minutes, and seconds. And you have to be able to add times together. And so what I'm thinking is, suppose I have a time that's 1 hour, 40 minutes, and 20 seconds. And I add to it another time that's 2 hours and 30 minutes and 10 seconds. Well, normally, the way that we consider times, I would expect this to be, okay, it's going to have 30 seconds, but then 40 plus 30 means we roll over into a new hour. So I guess it would be what? It would be 4 hours and 4 and 10 minutes. Or that's not 2, 4. And so basically what I'm going to ask it is, do we have to do that? I mean, we should. I really hope it's going to say yes. But if minutes rolls over above 60, do we have to then roll over into hours? Do we have to do a carry operation? Or am I allowed to have, 70 minutes, which seems really weird? So I'm going to ask it that. We'll see whether the model output helps me with that. So here I've got 9 hours, 30 seconds, 30 minutes, 45 seconds, 1 hour, 15 minutes, and 20 seconds. So here, this 45 and 20 should roll over. It should be 65, which rolls over to 5. And then 1 extra minute, instead of this being 45, it should be 46. And it looks like that's what it did. So I'm going to interpret this alone as sufficient to believe that when I add 2 times together, this is the behavior that I want. So the behavior that we all expect when I add 2 times together. All right, this is exciting. I actually am more excited for this than I was for either of the previous 2 exercises. So we'll go grab this, we'll paste it in, we'll save it. I'm just going to get a compile command ready. There we go. It's going to really throw a tantrum because obviously I haven't implemented a whole bunch of stuff, but we'll get there. Okay, so time. I'm going to need to have members, so hours, minutes, and seconds. I'm going to call the members HM and S because I'm going to need to use them a lot, and I feel like in the context of such a limited class, it's obvious what HM and S mean. We should be careful with one-letter variable names or one-letter member names, but I think in this context, because they're private, so nobody on the outside has to see them, and because I expect I'm going to use them a lot, I'm just going to call them HM and S. And then I'm going to initialize it, so I'm going to initialize H to the number of hours that you provided, M to the number of minutes that you provided, and S to the number of seconds that you provided. And I'm also going to add a little bit of error checking. So I'm going to say if minutes is greater than 60, or greater than or equal to 60, or if minutes is negative, well, that doesn't make any sense. You can't have a negative number of minutes. And there's a couple of ways I could handle this. One of them is I could say, okay, well, if minutes is greater than 60, then add something to hours. Like just try and equalize it yourself. But I'm not going to do that. I'm going to say that's your problem. So I'm going to throw an invalid argument exception. Invalid minutes. I don't think I'm going to add code to test this, but I just feel like this is good practice to make sure that we expect these to be constrained. And we want to make sure in this class that the number of seconds never exceeds 59. Like, we want to make sure that the times are valid. So I'm going to prevent anybody from constructing a time object unless they can provide valid parameters. I will not limit the number of hours, because I mean, without counting days or months or years, I guess I could make a time object that contains 4,000 hours or something. All right, so I initialize it. There's my constructor. I now define an overloaded operator. This should be pretty straightforward up until the point where I do the carry operation. Okay, so I'm going to do, I'm going to make, it's going to live in the class like before, so time operator plus, and it takes as its argument time const reference other, the other time object. And let's see, what's the easiest way of doing this? I think what I'm going to do is this. I'm going to make a new time object, and I'm going to set it to be empty. I'm just going to have it hours, minutes, and seconds are all 0. And now what I'm going to do is I'm going to say result.seconds, because I'm allowed to use the private members, equals the number of seconds in this object plus the number of seconds in the other. Okay, and then I'm going to say if result.s is greater than 60. Now, it's interesting because this is, if I know that both this time object and the other one are properly managed, there's no way that either of them can have a number of seconds stored internally greater than 59. That's impossible, which means that if the number is greater than 60, the largest it could be is what, 1 minute and 58 seconds? So it could be what, 118 seconds. So I think it should be sufficient to just write something like this to say, okay, well then, add 1 minute, so I say result.m equals 1. I haven't added all the other minutes in yet. And then result.s minus equals 60. And I claim that after this line, result.s is less than 60. If I didn't know that to be the case, I could also use a while loop. I could just say keep adding minutes, keep racking up the minutes as long as result.s is less than 60. But I'll try this. Maybe I'm wrong, but I'm pretty sure that as long as the time object is correctly managed, there's no way that you can add the number of seconds together and get more than 1 minute and 58 seconds out of it. Okay, so now I say result.m plus equals the number of minutes in this object plus the number of minutes in the other object. I do plus equals so that this extra minute I had to add here still gets counted. And then I say if result.m is greater than 60, then same story pretty much. Result.h equals 1 and result.m minus equals 60. All right, and then finally result.h plus equals the number of hours in this plus the number of hours in the other one, and then I return the result. There's my plus operator. I can't test it yet because I have to first at least define this operator. This is going to be the less than operator. For now, I'm going to leave it blank so I can test. And so it takes let's see, time const reference other, and then I'll just return false. And then I need an operator to do stream insertion. Just like before, that has to live outside the class. So I'm just going to write that quickly. And then it takes time const reference t, and then I suppose it's going to push it. Okay, so I'm going to start by pushing it in a pretty ugly way, and then we'll come back to this. So I'm going to push the number of hours, the number a colon, and then the number of minutes, and then a colon, and then the number of seconds, and then that's it. And then I'll return stream. Now, I believe I've done enough that I can compile the code, unless I've made a mistake. And I apparently have made a mistake. What have I done wrong here? Oh, yes. Okay, this is interesting. So I'm going to scroll up a bit and take a look at some other issues. So first, it says I'm using a private member. Okay, and that's because I lost my train of thought and forgot to finish doing this. I created the operator, but I never added the friend directive. So I have to add the friend directive. There it is. If I compile now, it did catch a second error. Let's take a look at that second error. So here's my new compile command. It's only complaining about one thing, and that's on line 59. And you could look at this and like, what could be wrong with this? We've already written 2 of these operators today. It says use of deleted function. Okay, well, fine. What's the function? And then it gives this horrifying expansion. I'm staring at this and I'm saying this appears to be a function in the OStream class. It's not called OStream in the library. Its real name is something else. But if I look at it, it's apparently called basic OStream, and the function is called basic OStream. That's a constructor. What does it take as its argument? It takes a basic OStream. So although there's a lot to read here, this looks like a copy constructor. It's saying you're trying to use this copy constructor, a deleted function. And I wonder, why would I want to use a copy constructor? It actually writes out a better looking version of that. Here's the signature of a copy constructor. It says it's been deleted. And you're trying to use it. And you might think, when did I say to use a copy constructor? And the answer was here. I accidentally forgot an ampersand. And so according to what I had until a minute ago, I'm trying to return a copy of an OStream. And we know already that OStreams can't be copied. So of course, if I try and do that, I get a compile error. So I'll try compiling again, having added back the ampersand. What are we complaining about? Oh, yes, right. So now it's complaining again about private members because it turns out that this friend directive no longer matches this operator because I've changed the signature. So I have to do this. That was a weird one. And I only spotted that quickly because I'm lucky. I think there in an alternate universe, I could have been struggling with trying to find that error for the next 25 seconds. So it could have taken a while to like look through it character by character. Okay, I think we're now squared off. Okay, so operators 3. All right, so the sum of these two times, so 9, 30, 45, 115, 20 is, it's going to add to 5 seconds and 46 minutes. That looks good. Now, in this case, I do want to do a bit more testing. Let's see if I set this to be 50 minutes instead of, and then I'll do 25 seconds. So it should now be what? 10, or it should be 11 hours and 5 minutes and 45 seconds. Okay, 11 hours, 5 minutes, 45 seconds. And now I'm going to see what happens if I have 2 carries in the same place. So here I do 55 seconds, which means a carry will happen on the number of seconds and on the number of minutes. And so I'm expecting what? I'm expecting 15 seconds and 6 minutes and 11 hours. 15 seconds, 6 minutes, 11 hours. Okay, so I've done the plus operator. Let's do the less than operator. How is that going to work? Well, I'm not modifying my times, and so I have to ask if one time is less than another. In other words, if the first time it says is earlier than the second time. Let's draw some times. Okay, so we'll do 6 hours, 5 minutes, and 20 seconds. 10 hours, 17 minutes, and let's do 3 seconds. So the idea, I think, is that this time is considered earlier. Well, first, we'll check hours. Because it doesn't matter how many minutes and seconds there are. If I have 6 hours versus 10 hours, then this time is definitely earlier, because 10 hours is longer than 6 hours. Now, suppose they both have the same number of hours. Well, if they have the same number of hours, then I break the tie by looking at minutes. And if minutes is less, then this time, the first time is earlier. So in this case, the first time is still earlier. If the number of minutes is the same, well, then I look at seconds. And the first time is less if the number of seconds is less. So I just do a stack of if statements. And if I get to the end and I haven't yet found something that's less, then I guess it's not less. So if I get all the way to the end and I say, here's 60501. Oh, no, wait, 04. So in this case, the second time is earlier. And even in cases where they were equal, you want to return false. The less than operator returns true only if the first time is earlier, not if it's the same. So I guess what I'll do is say this. I'll say if h is less than other.h, well, then I return true. Actually, I could even, yeah, okay, I'll do this. Then I return true. Now, otherwise, if h is greater than other.h, well, then there's no way. So here, even if everything else is equal, if I have 10 hours in one and 6 hours in the other, there's no point in looking at the number of minutes. So in that case, I know the answer is no. Then I return false. Okay, so if I'm down here, at this point, h is equal to other.h. That's the only possibility left. So I just repeat the process, but with minutes. If m is less than other.m, then I return true. If m is greater than other.m, then I return false. And then at this point, h equals other.h and m equals other.m. And now I can just return whether or not s is less than other.s. That's all I need to do, because if the two are completely equal, then s is not going to be less than other, and then the less than operator should return false. So we'll try this again. All right, so T1 is 9 hours and 1 minute, 9 hours, 50 minutes. T2 is 1 hour, 15 minutes, and that means that T1 is not earlier. Let's try this again, but with 0 hours and 50 minutes. So now T1 is earlier. And we can see that the answer is true. That's good. Let's try flipping them. So we'll do 55. So now we'll make them a tie and then 55. So now T2 should be T1. Oh, I did that in the wrong order. Okay, 45. So now T2 is earlier again. So I should get the answer false from that operator. And I do. Okay, let's make them both have the same number of minutes and see what happens if T1 is earlier. So that should be true. Okay, and now let's see what happens if T1 is later. That should be false. and then we'll see what happens if they're exactly the same, which should also be false, because T1 is not less than T2 unless it's different from T2, and it's also false. All right, so one more thing. I've now completed the exercise as far as I'm concerned, but let's do, okay, 1 hour plus 2 hours. I'm going to do 3 minutes plus 4 minutes, and let's do 50 seconds plus 11 seconds. And I want to take a look at the result of adding them together. So the sum of times is 381. This does not look like a time. It doesn't. Why not? Well, because we're used to times, except for hours, we're used to minutes and seconds always being printed in 2 digits. So I'm done the exercise. This is something, I'm just going to do this next bit in my leisure time. I'm done the exercise, but maybe now finally it's time to use those annoying output features of C++ that allow us to render numbers in a format of our choice. So not just settling on the default rendering of numbers. In this case, what I want to do is force it to render my integer values in 2 digits, even if they are only 1 digit long. What I'm going to do to make that happen is I have to be careful how I ask, because I don't want ChatGPT to give me the answer. Can you give me an example, not part of the exercise above, of C++ code that prints an integer using 2 digits instead of the default formatting? So C++ has this feature. It's a library header called iomanip, I think, that we need for this. I can't remember how to use it off the top of my head. That's one of the reasons it's not on the exam, is that like a lot of output formatting, output formatting is very complicated because everybody has different preferences, and it's not worth memorizing because you can always look it up, and because there's such weird pedantic distinctions involved that it's not really worth memorizing one way of doing it, because you change jobs or do a different project and somebody has completely different demands for how the output should be formatted. So I'll ask ChatGPT to give me an example and see if it can remind me what I need to write. Certainly. So it says, yes, use the iomanip header, and there are these 2 things. Set W is to force it to use a certain number of characters to write a number, but if you say set W and ask it for 2 characters, it'll still use only 1 digit. Set fill is for what you do to fill in all those extra digits. So I think it's this. And the syntax is very weird. So if I want to print the number 7, does it give sample output? Yeah, so here I'm printing the number 7 and it prints as 07. If I want to print a number using a particular format, I call these functions and I push the result of the function into the stream before the number. That sort of tells the stream that we're about to get a number I want printed in a certain format. So it's this combination that I want when I print my times. So in my print operator for times, I'm going to jam these special formatting tokens into my stream before I print out the times, and I have to add iomanip. Okay, I'm going to run this, and I want to show off sort of a property of this weird formatting token approach. As I mentioned, I think in the last video, C++20 brought in this new output formatting convention that supersedes this annoying and clunky business, the whole stream insertion operator thing. It just hasn't been widely adopted yet, so I can't use it in 1.16. I want to, but I can't. Okay, I compiled, it worked, I run it, and we can see here, yeah, now it's printing 03 instead of just 3. But notice that the 8 and the 1 still get printed in 1 digit. And the reason is because these modifiers are temporary. They're just used for the next value that gets printed by the stream. And this is going to make the result even more clunky, so I'm going to spread it over multiple lines. So I'm just going to break this down into a whole bunch of smaller print statements. And then I'm going to realize I've made a pretty big faux pas here, which is, this is a print operator. I should be pushing into stream. I shouldn't be pushing into cout. I shouldn't assume the stream is always going to be cout. So I'm going to fix that. So when I use the output formatting tokens, so set W and set fill, what I'm doing is I am changing the format that's going to be used for the next number that gets printed. And so that means every time I print a number, I have to push those tokens in to force it to change format. So I'll do that. We'll just run this. Okay, now it's printing like an actual time. Okay, one last point at the end. So I use two of the modifiers. Let's see what happens if I use only one of them. So suppose I just use set W. What set W is saying is, I'm going to give you a number. I want to make sure the number gets printed to a width of at least 2 characters. So you have to use 2 characters to print this number out. And I try running this without the set fill, and we can, oh, and it worked. Okay, well, that's peculiar. Why did ChatGPT make me use both? Really? Is that going to... All right. Oh, actually, maybe set fill does stick. So if you notice my fumbling, you can see that I'm not terribly fond of this convention. Yeah, okay. So I'm going to use set W and then set the width to 5, just to make it really obvious what set W actually does. Notice how it is apparently printing this 1-digit number in 5 characters, but by default, it pads the number out with spaces. So the set fill modifier is what you use to tell it what you want the extra characters to be. When it has to fill in extra characters, what fill characters should it use? Here I'm saying use the digit 0 because that's what we expect for numbers. So now I'm printing my number 3 with 5 digits instead of 2. I'm going to go back to, actually let's experiment a bit more. I can set this to any character I want. So I can set it to the letter X. And we can see here now it pads with the letter X. So I'm setting it to 0. Okay, now what was the thing I fumbled with a minute ago? What I noticed a minute ago was this weird issue, which is that when I've already run set fill of 0, it looks like the fill character stays at 0 even if I print the number and start on a new one. So here, if I get rid of set fill, it still works, which is sort of creepy and weird because set W doesn't stick. So if I delete the set W call, which we'll do, then set W apparently needs to be redone at every moment. Every time I print a number, I have to say I want it to be at width 2. So what have I learned from this? Well, okay, if I want to format output in C++, it's a huge pain compared to printf in C, and also the modifiers behave in a weird, erratic way. Some of them stick, so the set fill modifier sticks. Once you set it, you don't have to set it again. The set W modifier doesn't stick. You have to keep using it because it resets after each use. That's a huge pain. But now at least my program is printing out times in a nice representation. So it's nice to put the extra polish on your program. It's a huge pain to do C++ output formatting.